Hey, welcome back. So we're again talking about some more domain and range. It's a really good topic to talk about. It does apply to a lot of real life situations like we saw with the multiple choice questions yesterday. We're going to do some more questions today that also deal with multiple choice in our Regents exams. But again, let's start off with some of the basics. State the domain and range of the given relations, and I want you to decide if it's a function. So let's start with domain and range. I'm going to use the letters D and R just to save some space. If you recall, domain is the X values, range is the Y values. So for points, I'm just going to make a quick list of the X values. I'm going to go through the points and take the first in each parenthesis. Those are my X's. And I'm going to do the same thing for range, except I'm going to go back and do the Y value. So the second number in each parenthesis represents my Y values. And I'm done. So again, remember our points have X's and Y's. X's are first, Y's are second. For graphs, again, I like to look at the axis itself. So here's my X-axis. The graph goes as far left as this point right here and as far right as this point right here. So here is all of the X values are in between these two numbers right here. So I'm kind of creating like a boundary almost. So I'm going to list those numbers here. Since this is 0, this is going to be -1. And then as far right as it goes, this is 1, 2, 3. And then I'm going to decide X in the middle, because we're talking about domain, decide on dots. This one, since it's an open dot, is going to get a less than sign. Moving over here, I have a closed dot, so that's going to get a less than or equal to sign. And that is my domain. I'm going to switch colors so you can see my range. We're talking about our Y values. So how high does this graph go on my Y-axis? Goes way up here. Right, that's as tall as this graph goes, and as low as it goes to here. So again, my Y value, whoa, super crazy. Let's try that again. I don't know why it got all wobbly on me, but it did. Still a little wobbly. All right, there we go. So how high does this go? Again, we're talking about Y's. It goes from 1, 2, 3. That's the highest it goes. Also down -1. How about that? And I got an open dot here, so it's going to be a less than sign. And got a closed dot up here, so it's going to be less than or equal to. How about that? Oh, I forgot to answer the question. Is it a function? So is this a function? Remember, when we look at graphs, we're talking about the vertical line test. Does this graph pass the vertical line test? No, it's not a function. Remember, our vertical line test is a test that if I draw any vertical line anywhere on this graph, if it crosses more than one point, and look at that, it just hit 3 points, right? So it failed the vertical line test. When we're talking about values, I'm talking about X's repeating. Is there an X that repeats to a different Y value? So again, think about that point, right? This point is 2, I don't know, 0.5. This is 2, 1.5. This is 2, 3. So you notice these points all have the same X values, but different Y values. So that's what makes it fail the vertical line test. So do I have an X value that repeats that has a different Y value? No, I don't. So that means this is a function. Yay! All right, so we're going to move on to another multiple choice question similar to what we did yesterday's video, and then we're going to do 2 more evaluating domain and range questions. Okay, so another word problem, multiple choice. This came right off a Regents exam from 2017. The daily cost of production in a factory is calculated using C of x equals 2x plus 16x. where X is the number of complete products manufactured. X is the number of complete products manufactured. Sounds fancy. We're talking about products. We're just talking about things. And manufactured just means made. So, things made, right? So we're just making things in a factory. And this is how many complete items are made. And then the C of X represents the cost. Which set of numbers best defines the domain? So again, we're talking about the domain. We're talking about our X values. And so in this case, we're talking about the number of things that we made. So remember, things that we make can't be negative numbers. Can't be, it's like people. It can't be a half. Can't be a 0.2. Right? So think about that. So numbers that describe things. So we're looking for like 0, I can make 1 thing, I can make 2 things, I can make 3 things, and so on. What kinds of numbers describe that pattern? So integers. Remember, integers are positive and negative. So we cannot have negative things being made. Positive real numbers, positive rational numbers, and we have whole numbers. So let's start with whole numbers we know, right? We're talking about these kinds of numbers. Rational numbers are our fractions and decimals, which if we're talking about whole things being made, right, we can't have that. Real numbers also include fractions and decimals and integers and all of these all together. So again, cannot include real numbers. So my correct answer is whole numbers. So like 0. Whole starts with 0, right? It has a 0 in it, and then it goes 1, 2, and so on and so on. Those are my whole numbers. All right, 2 more questions and then we're good to go. Here we go. Okay, so evaluating domain and range. If f of x equals 2x minus 4 is defined on the domain, x is somewhere in between 2 and 6, the range of this function is, so again, we're talking about our y values, or in this case, our f of x values. Domain obviously represents our x. So notice what I set up here. I set up an f of 2. So instead of x, I substituted in 2 because they gave me that value. And so in the function, I'm going to evaluate it where the value of x is 2. So 2 times 2 minus 4, I'm going to get 0. How about that? And then the second one, I'm going to do the same thing and repeat it, except I'm going to use 6. 2 times 6 minus 4. So that's 12. Take away 4 would make 8. So my range is going to be using, remember, I'm going to use the same kind of notation that they used. I'm going to use 0 as my lowest number, 8 as my highest number, y in the middle, because we're talking about range. And then we know that these values equal, because when I substitute in 6, I get an equal 8. I don't get less than 8, I get equals 8. And same thing when I substitute 2 in, I get equals 0. So my final answer, my range is between 0 and 8. And my next question is very, very similar. Again, they want to know what the range is of this function given the domain. So again, my domain, we're talking about our x values. So I'm going to have to substitute in each one of these. So I'm going to have to write an f of 0 and plug in 0, an f of 1 and plug in 1, and f of 2 and plug in 2. Once I have those 3 answers, those will be my range. And I'm going to write it the same way they wrote the domain up on top. They wrote it with 3 numbers. My answer will be 3 different numbers, and I'm just going to write them here. I'm not going to show you all the work, but I will show you the first substitution. Remember, I'm going to take that function up here, except where I see the x. The first time I'm going to plug in 0. The second time I'm going to plug in 1. And the third time I'm going to plug in 2. And whatever I get will be those 3 answers that will go in my range. All right, looking forward to you to finishing that up, and I will see you soon.